Okay, so we're finishing up Unit 3 today. Okay. And so that means this week the 6.4 assignment and then the reviews will be due. So when you all come to class on Tuesday, that'll be test day for Unit 3, and we are testing, I've already forgotten, I just showed some of you all what it was. We are testing in TCE 209, which is 2 buildings down upstairs. I will send that out a couple times on text so that you'll have it on your phone in case you don't remember before coming in. So I'll send it out when I remind you what's due, and then I'll send it out again about 15 or 20 minutes before class starts on Tuesday. So our test will be Tuesday over Unit 3. Okay? Don't forget that I've got that review video where I go through each problem. So use that if you get stuck on anything. That should help you out. And then you can use your 1 page of notes. And then this last section has what we call the chi-squared distribution table that you need for it, and it is not something you can find on your calculator like we were doing with the z-scores and the t-scores. So I will bring you a copy of that table as well, a hard copy for the test. But then I have it posted in this PowerPoint, and then I also have it in the PowerPoint sections, its own link, so you can find it easily there. Okay. So today we're going to look at how to interpret the chi-squared distribution and use a chi-squared distribution table. We'll look at how to construct and interpret confidence intervals for a population variance and standard deviation. So for the chi-squared distribution, the point estimate for the variance is going to be our sample variance, S squared. The point estimate for our population standard deviation is going to be the sample standard deviation, S. S squared is the most unbiased estimate for our population variance. So you can use the chi-squared distribution to construct a confidence interval for the variance and standard deviation. If the random variable x has a normal distribution, then this is our formula that we'll use for chi-squared. And so this kind of fancy looking x squared, that's our symbol for chi. Okay. So chi-squared is equal to n minus 1 times s squared divided by your population variance. So this forms a chi-squared distribution for samples of any size n greater than 1. Okay, so you're definitely going to want to write this formula down and have that for your formula sheet on Tuesday, because we will be using it a lot through this section. Okay, so here are some properties of the chi-squared distribution. All chi-squared values are greater than or equal to 0. The chi-squared distribution is a family of curves, each determined by the degrees of freedom. To form a confidence interval, we're going to use the chi-squared distribution with degrees of freedom equal to 1 less the sample size. So just like we saw last week, our DF is going to be n minus 1. And then the total area under each chi-squared distribution curve is equal to 1. The chi-squared distribution is positively skewed, and therefore the distribution is not symmetric. The chi-squared distribution is different for each number of degrees of freedom. As the degrees of freedom increase, the chi-squared distribution approaches a normal distribution. So you can see on our black graph here when the DF is 2, and then on the gray graph, the DF is 5. It's starting to take more of the shape of the normal curve. It's just not symmetrical. DF kind of shifts it over a little bit there in blue, the DF of 10. DF of 15 is our dotted black graph, it's shifting it over even more. And then a DF of 30, that larger value, it starts to look more like our normal distribution. Okay, our critical values for chi-squared, we have 2 critical values for each level of confidence. Chi-squared R represents the right tail critical value, and chi-squared L represents the left critical value. You may notice this time the blue part is representing our area, and this time the area is to the right. Where everything else we've looked at, the area has always been to the left of the critical number. For chi-squared, it is to the right of the critical number. Okay? So to find the chi-squared R, you're going to take 1 minus C and divide by 2. To find chi-squared L, you're going to take 1 plus C and divide by 2. So you can conclude that the area between the left and right critical values is your C, your confidence interval. So on this first example, we want to find the critical values chi-squared R and chi-squared L for a 95% confidence interval when the sample size is 18. Okay, first we need to find our DF. So the degrees of freedom is going to be n minus 1. Since it told me in this problem that the sample size is 18, that makes n 18, so 18 minus 1 gives me a DF of 17. Remember, each area in the table is going to represent the region under the chi-squared curve to the right of the critical value. And so the area to the right of chi-squared R will be 0.025. And that's going to make the area to the right of chi-squared L 0.975. So knowing that, I'm going to look on my chi-squared table and I'll look up the degrees of freedom will be in the first column. I look up 17, and then the chi-squared L was 0.975, so I look that up and that gives me a value of 7.564. The chi-squared R, the area to the right of it was 0.025, so when I look that up, I have 30.191. So those are our 2 critical values, 30.191 and 7.564. Now, once again, most of these problems on MyLab will have the chart where you can just click on it in the table, but I am including it at the very end of this PowerPoint. There's your table where you can look up. We looked up 17, and then we went over to 0.975 there, and over to 0.025 here to get our value. So it's the last slide of this PowerPoint, but then I also included it here in the PowerPoint Unit 3 folder. Right underneath the 6.4 PowerPoint, I have the chi-squared distribution there. So when you click on it, this is what you get, okay? But I will bring you a hard copy of that just in case you have any problems on MyLab, because occasionally they just won't include the table for some random reason. So I'll have some paper copies of that in case you come across a problem like that on the test. Okay. All right, where were we? So for the example we just did, for a chi-squared distribution curve with 17 degrees of freedom, 95% of the area under the curve lies between 7.564 and 30.191. Okay. So any questions there? So do you understand how to, I think the degrees of freedom is pretty easy to look up. Do you understand how to find the value at the top, like why we looked up 0.025 and 0.975? We're good on that? Okay. Like I said, the hardest thing on this is to remember it's referring to the area on the right instead of the left, like we did before. Okay, so here's our formula for the confidence intervals. For the variance, we're going to take n minus 1 times s squared and divide it by chi squared r. N minus 1 times s squared, divide by chi squared l. And then standard deviation, you'll just take the square root of each of those. So I know we used our calculator for all the other confidence intervals, but for whatever reason, that is not an option for the chi-squared stuff. Okay. So you're going to need to have those formulas down so that you can use those on your test. Okay, the probability that the confidence interval contains the variance or the standard deviation is C, assuming that the estimation process is repeated a large number of times. Okay, so here's our little table like we do in every unit where it kind of summarizes how to find everything. So you may make a note that this is going to be on slides 15 and 16 if you want to see kind of the shortcut version of what the previous slides have said. So to construct a confidence interval for variance and standard deviation, the first thing you want to do is verify that the population has a normal distribution. Then we want to identify the sample statistic n and the degrees of freedom, remembering that df is equal to n minus 1. Then we want to find our point estimate. Okay, that value, we typically did not use our formula. We used our one variable stats on our TI-84. Your one variable stats, remember it tells you S, but not S squared. But if we know S, we can find S squared, right? Okay. Definitely easier than using this formula because that was where we had to do all these sums and it just took a while. Okay. Okay, but then that's pretty much the only place you're going to be able to use your calculator to help you out other than just using it for the arithmetic. Next on step 4, we're going to find our critical values, chi squared r and chi squared l, that correspond to our given level of confidence C. We'll use our chi squared distribution. Once again, I have that table on Blackboard or it's on our last slide of this PowerPoint if they don't offer it to you on your MyLab problem. Okay, then we'll find our left and right endpoints and form the confidence interval for the population variance. There's the formula there. We want to find the confidence interval for the population standard deviation. So we'll just be able to take what we found there in step 5 and square root each of those left and right endpoint values. Okay, so let's go through all of that in this next example. Okay. So we randomly select and weigh 30 samples of an allergy medicine. Okay, so that first number 30, what is that? N. That's our N. Okay. So that's telling me my DF is going to be what? 29. Okay. All right, the sample standard deviation is 1.2. So that's S. Assuming the weights are normally distributed, construct a 99% confidence interval. So what's the 99%? C. That's our C. Okay. For the population variance and standard deviation. So as you read through a problem, you're going to name those parts like I just did. Okay. And then go through and figure out what we need to look up on our table. Okay. So the area to the right of chi squared r is going to be 0.005, because if our confidence level was 0.99, that leaves 0.1 to be split between those two ends. So the one on the right, you're looking at the area on the right, so half of 0.01 would be 0.005. Then to the left, it's going to be 0.995 for the left critical value. Okay, we're going to look those up on our table. And so when I look those up on the table, I'm looking at 0.005 and 0.995, and then remember our DF is 29. So here's 29, and let me write on this. Oh, we're going to look at 0.995, so that one is here, 13.121. Okay. And then the 0.005, yeah, you're going to get a little cross-eyed here, but at least this one's in the first and last column. We've got 52.366, it looks like. So definitely use your magnifier there when you can. You all don't have as old eyes as I do, so you may not need it as much, but yeah, I struggle on these. More than likely, if you make a mistake, you probably looked up, your eyes kind of went below or above, and you probably grabbed the wrong value there. So I think a paper copy, I always find it easier to look up the numbers on the paper copy, so I'll get you that for the test so that you won't have that anxiety of that, looking at the wrong table there. Okay, so there's our two numbers. The chi-squared R, 52.336, chi-squared L is 13.121. Is everybody good with those? Okay, so now we need to use our formulas for the left endpoint and the right endpoint. So I'm going to take n minus 1. That's 30 minus 1, or 29. And then remember, our S was 1.20, so I take that and square it. And then I'm going to divide that by my chi-squared R, which was 52.336. When you put that in your calculator, you'll get about 0.80. So just pay attention to how MyLab wants you to round. Okay. Then we need to do the same thing for the right endpoint. Okay. Now, this can be a little tedious because you're using this formula twice, but remember you've got that copy feature on your calculator. So once you type this in, just highlight it, copy it, and then change your denominator, and that'll save you a little bit of time. So this, the only thing that changes between the left and right endpoint is your chi-squared R changes to chi-squared L. Okay. So now I'm going to change that denominator to 13.121 and get 3.8. So that makes our confidence interval for the population variance 0.80 to 3.18. Now, when you want to find the confidence interval for the standard deviation, then you just take the square root of those values. Okay. So right now, with 99% confidence, you can say that the population variance is between 0.80 and 3.18 milligrams. And then don't go through and use the formula again. You've already found the value for this. That was 0.8, so you're just going to do the square root of 0.8. And then the value for this, you found, what was it, 3.08, is that right? I forgot what was on the last slide. You'll do the square root of that. Okay, so save yourself some time there. Don't worry about using the formula again like they did. You'll end up with 0.89 and 1.78. Okay. Now, when you do the square root, you can be more accurate if you'll go up and copy the decimal. Like if you rounded to 2 places to put it in MyLab, go back up and copy the original number and take the square root there. That will keep you from being off by a tenth or 100 and getting really frustrated on MyLab, okay? So with 99% confidence, you can say that the population standard deviation is between 0.89 and 1.78 milligrams. Any questions on that one? All right, here's your few try problems. So these match up with 5, 8, and 9 on MyLab. So take a second to see if you can work through those 3 so we can make sure you're in good shape before we wrap things up. 5, your chi-squared L is 12.879, and chi-squared R is 46.963 when you round to 3 decimal places. So I made a note over here of what you should look up on the chi-squared table. 0.01 for right and 0.99 for the left. Are you good with that one? Okay, then for number 8, when you find that confidence interval, I took a screenshot of my work here. It's a little messy, but hopefully that helps. And, you know, we haven't had to write down a whole lot from math. I know some of you kind of resist that even in algebra. For this class, you've been able to get by with not writing much down because we do so much on the calculator. But here, write some stuff down so that you don't get yourself confused since we're not using our calculator here. Your C was 0.95, your S was 37, and N is 17, making your DF 16. So my chi-squared L is 6.908, and my chi-squared R is 28.845. And so when I use my formula for the right endpoint, I'm taking 16 times 37 squared, dividing by 6.908, and that gives me 3,170.82. So that's the one on the right. That's the right endpoint. And then for the left endpoint, 16 times 37 squared and divide by 28.845. So that's the left endpoint is 759.36. Okay. Now, I was getting myself confused working through these, which one was the right, which one's the left. But then remember, if it's the smaller number, it's going to be on the left. The larger number will be on the right. So if you find yourself doing the formula and you're like, which one was this? Okay, work through the other one and don't make it harder than it needs to be. Okay, like I was doing. All right, and then to find the population for the standard deviation, remember you're just going to take the square root of this number, square root of that number. Don't go through and work out the formula again. Unless you're just bored and you want to put all that in your calculator. Okay, but that'll give you those values there. Okay, then for number 9, here's my work for N, DF, S, and C, and then working on the endpoints, you end up with 6.26 and 30.89 for the confidence interval for the population variance. And then this is one where they're wanting you to interpret the results. So you would say, since your C is 0.95, you would say with 95% confidence, you can say that the population variance is between 6.26 and 30.89. And then square root those to get your confidence interval for standard deviation. Any questions there? Okay, so like I said, a lot of the same stuff we've been doing, but this one is a little more challenging because you can't rely on your calculator for it to get those critical numbers, and then you got to remember that you're looking to the right. So when you find your numbers there to look up in the chart, keep that in mind. Okay, we're ending early, but you all have a lot on your plate this week with getting this one finished and then working on the review. Reach out if you have any questions. I'll be happy to help. And then don't forget the video examples folder.